So in these problems, we're going to solve logarithmic equations, and we do need to remember to check our solutions at the end to make sure they work in the original equation. So let's start with 109. I have the log base 4 of x plus 5 plus the log base 4 of x minus 1, and that equals 2. So the first thing I can do is I can combine these two logs together into one expression, and that makes the log base 4, because they have the same base. They would have to. You're not going to see a tricky question where one of the bases is 4 and the other base is something else, so that's not really something to worry about, but they do have to be the same. And then because we have addition here, we're going to multiply the two binomials together. So we have x plus 5 times x minus 1, and we say that that equals 2. Now I can take this logarithmic expression and turn it into an exponential expression. The base is 4. The exponent is 2, because in a logarithmic equation, the exponent is always on one side by itself, and the quantity that the base to the exponent is equal to is going to be by itself now. So that means that we have 4 to the power of 2 equals x plus 5 times x minus 1. And of course 4 squared is 16, and I'll have to multiply these binomials using FOIL. So I have x squared minus x plus 5x minus 5. Now I'm going to get everything on one side equal to 0, combine like terms, and I'm moving the 16 over. That means I'm subtracting 16 from both sides. So now I have x squared plus 4x minus 21. And this is factorable. So I can factor this as, let's see, 21, that's going to be 3 and 7. We want the 4 to be positive, so it's a plus 7 and a minus 3. So I get x equals 3 and x equals negative 7. I'm immediately suspicious of any negative answers, but I have to check both of them in the original equation. So we can't take the log of a negative number. So what I do is I plug in our numbers, start with 3. That gives me the log base 4 of 3 plus 5 gives me 8, that's okay, plus the log base 4 of 3 minus 1, that's 2, and that's okay. And does that equal 2? So we multiply the 8 and the 2, just using the properties of logarithms, as we did before. But really at this point I know I don't have the log of a negative number, so everything should be okay as long as I did my computations correctly. And this checks, right, because 4 squared equals 16. So 3 is a good answer. I was more suspicious of the negative 7 anyway, so now let's check that. Oops. We have the log base 4. Negative 7 plus 5 gives me a negative 2. Can't have the log of a negative, so the negative 7 is out. I don't need to go any further. So if I had kept going and plugged in the negative 7 to the second logarithm and multiplied, I would have had two negatives multiplying to make a positive. So that might seem like it works, but that's why we get that extra solution that doesn't really work. So it has to work in the original. So don't go any further if you see that you've got the log of a negative. You just throw away that solution. And so the x equals 3 is the only answer there. Now let's take a look at 110. Here we have the log base 9 of x squared minus 8x equals 1. So this is pretty similar. I actually have less steps to do here because I don't have to combine two logarithms. So I can go directly to 9 to the power of 1 equals x squared minus 8x. And of course 9 to the power of 1 is just 9. So I'll subtract 9 from both sides. And that gives me 0 equals x squared minus 8x minus 9. And this will factor. And it should be a minus 9 and a plus 1. So we get x equals negative 1 and x equals positive 9. So again, two solutions. Let's check both of them. So now the original equation was the log base 9 of x squared. I'll try that negative 1 first. Negative 1 squared minus 8 times negative 1. And does that equal 1? All right. So negative 1 squared is 1, and that's going to be plus 8, and 1 plus 8 gives me 9. So that works. So you can see, just because a number is negative, it doesn't mean that it has to be a bad answer, but you definitely check it. And now let's try 9, plugging in there, and we have the log base 9 of 9 squared minus 8 times 9 equals 1, and that'll be 81 minus 72 gives me 9. So in this case, both answers work. So we have two solutions. Now in 111, we have the log base 4 of x plus 5 equals 3 plus the log base 4 of x plus 2. And I want to get my two logarithms together. So I can do that by subtracting the log base 4 of x plus 2 from both sides, because I want to write them as a single logarithm, and once I have that, then I can convert to exponential form. So now, because we have a log minus a log, I can write that as a single logarithm, log base 4, of x plus 5 over x plus 2. Because it's subtraction, that's when we write a quotient. And the 3 is left on the other side. Now I'm going to change to exponential notation, so I get 4 to the power of 3 equals x plus 5 over x plus 2. And 4 cubed is 64. So let's squeeze that in there. Okay. So now, continuing to solve, I'll multiply both sides by x plus 2. And that gives me 64x plus 128, because I'm distributing that 64, equals x plus 5. And I can subtract the x over, that gives me 63x, equals, subtract the 128 over, that gives me a negative 123. This is coming out like a horrible looking number. So x equals negative 123 over 63. And let's see. If I plug that back into the original equation, I figure out where to put it. Okay, let's go up here to the top. So I'm checking my solution, and I have the log base 4 of negative 123 over 63 plus 5 equals 3 plus the log base 4 of negative 123 over 63, oops, squeeze that in, plus 2. If I subtract 5 minus 123 over 63, I get a positive answer for that. And the same thing if I take 2 minus 123 over 63, I'm going to get a positive for that as well. So this is a good solution to the problem. So that works. And you can check that on your calculator and see that the computations come up correct. And for 112, we have the natural log of x plus the natural log of x plus 1 equals the natural log of 56. So on the left-hand side, we can combine our two natural logs and say we have the natural log of x times x plus 1 equals, on the other side, the natural log of 56. So since we have the natural log of something equals the natural log of something, those two somethings must be equal to each other. So I can just essentially drop the natural logs. It's not really what I'm doing, but for our purposes, it's fine to think that way. So whenever you have the natural log of something equals the natural log of something, or whatever kind of logarithm it is, then as long as they have the same base, you can just drop the logarithms. So I distribute and I get x squared plus x equals 56. Bring the 56 over to the left. And factor. That's going to be 7 and 8. And the 8 is positive and the 7 is negative, which gives me x equals 7, x equals negative 8. So going back to check, 7 is going to work in both cases, in the natural log of x and the natural log of x plus 1. And if I plug in negative 8, obviously that's going to not work immediately. So our only solution is x equals 7. So that's how you solve those problems.